Okay, so if you look at the course at a glance, it tells us there are 4 units, 1, 2, 3, 4. We don't have to do the 4th unit. So if you look at the back of that pink sheet, you can cross it out. The AP exam is only 3 units. This unit is optional, and Pinellas County has said we're not doing it. So we are currently today starting 1.1, and most of the time we take 2 days to do each section, okay, most of the time. If you look at this first unit, it shows that there are 14 sections in that unit. The lady, I keep saying she added all these examples to the section, or I don't like the problem she did. The lady that created the curriculum that I just handed you, she incorporated 9 through 14 as one section. So what I'm giving you, we're basically calling it 9 sections, but it will cover all 14 that will be on the exam. I broke up these sections into 2 tests. The first test will be 1.1 to 1.5, and the second test will be 1.6 to 1.9, and that will finish Unit 1 a little bit before first quarter is over. Then we'll start Unit 2, which will take us all the way to the end of the semester. So our midterm exam in this class will be these 2 sections, these 2 units, okay? When we come back third quarter, we will work on the final unit. It'll take us a little bit even into fourth quarter, and then we'll have exam review, and then the AP exam is May 13th in this class. So really, there's only 1 unit after the semester. So that's why I want you to keep this in here. We'll refer to it now and again, and anything that's pink stays in here. And then you can organize your notes and homework however you want to organize it. It just matters that you know where everything is. That's all that matters. Because there will come a time when I have time to explain how I do homework checks, and it's all about you knowing where stuff is in your notebook. The pink sheets, I am going to have an incentive for you guys to keep them in your notebook, and that is extra credit. Every once in a while I'm going to say, okay, everybody open your notebook to the course at a glance sheet, that sheet I just gave you, and I can basically do it from my seat. And if you open it and I see it, I'm going to mark you down for extra credit. Okay, throughout the year, or I'll say, I want to see your calculator tip sheet, which I haven't given you yet. So it's just incentive for you to keep it in your notebook to look back at, including the Algebra 2 review, because that's stuff that you need to know how to do all year. Now, having said that, let's talk about that quiz yesterday. We had some really good grades, and we had some not so great grades. So I'm going to tell you what you can do if you didn't do well. And you might not have seen it, because unfortunately, being 7th period, I didn't get to grade them until this morning, and then I put them in this morning. So you may not even know how you did. I'm sorry, I'm trying to take attendance at the same time as I'm talking. I'm almost done, I promise. Lauren, not here. Lauren G. What's here? Oh, she dropped it. She dropped this class. I must have made a bad impression on her and Stephanie. Okay, so sorry, guys. It's so much I have to do. It's so hard to be me. Oh, she dropped it too. Okay. All right. So let's look at the grades. So let's see. Did anybody in this class get a perfect score? Yes. So, Kayla, where's Kayla B? Kayla had a perfect score. And Cameron Kimball, where's Cameron? Cameron, good job. And Esther had a perfect score. So, those 3 did great. Yeah. Now, can you wait? I don't want you to miss any of this stuff. And if it's an emergency, go, but I'd really rather you wait till I'm done talking. If you did not get a perfect score, I'm going to give you guys a one-time chance to make it up, okay, if you do something for that. So listen, the reason I gave you that quiz was not like to waste your time or my time. It truly was because it's such important stuff. You're going to see some of it's even going to pop up today, like that was on that quiz. I'm going to give you your quizzes back next week when I'm done with the makeups. And then I'm going to post the key on Canvas for you to see. And if you want to retake that quiz, you need to do quiz corrections. Fix anything you did wrong looking at my key. Then there will come a day, and I don't know when yet because I have to get the makeups done, but I'll say to you, okay guys, next Friday is going to be that opportunity to make up that quiz. And I'm going to do like the last 10 minutes of class for anybody that wants to do it. I'll say who wants to do it. They will give me their quiz corrections. I will give them the new quiz. The new quiz will be very short, 5 or 6 questions, not 15. So you really have to know it. And then easier for me to grade, not using as much class time. And then I will keep the higher of the 2 grades, okay? So you all have an opportunity to get rid of the grade. Even if it was a 29 and you're mad at yourself or whatever, you did lose 1 point on there, you can retake it. And I will keep the higher of the 2 grades. So that's coming, okay? Anybody have questions about that? Good? All right. And I don't do that for any other quiz. This is just that important. I do drop your lowest quiz grade, so there's that. But you want to save that for later, maybe, for the harder stuff, not the review stuff, maybe. Okay, so it's going to take some getting used to, all these papers I just handed you. We'll adapt to it. Understand the way she writes it, the lady that made this, she writes 1A and 1B. I kind of call it day 1 and day 2. It doesn't matter to me how you do it, okay, but you'll see me writing that up. So day 1 is like A, day 2 is B. And the notes are right back to back. We have 1A notes, then 1B notes. So that will be Monday. And then all the homework is behind it. And I'll tell you about that when we get to it, right? I also don't do every single example, and I don't assign every single homework problem. So as we go through the notes, I might cross things out because it's redundant, repetitive, or it's coming up later, so we don't need to cover it now. So just understand there's a reason, okay? All right, so let's get started. Starting with a function is a mathematical relation. And I'll come back to what a relation is in a minute. It's just a set of ordered pairs with input and output values. Inputs are x's, outputs are y's. And a function is such that each x value is mapped to exactly one output value. And I always used to think in my own brain that that was a confusing way of explaining it. I would rather you think of it, I think it's easier to think of it as no repeat x values. Okay, so this is probably not a new concept, you guys, determining if something's a function. Vertical line test, we'll see too. The input values are called your domain. So all your x values, your inputs are domain. Your outputs or y values are range. We know this, I believe. Okay, and she talks about this rule of 4, not something you have to memorize or anything, but it's just basically saying there's lots of ways to express a function as a graph, which is a picture, numerically like an XY chart or mapping diagram or something like that, algebraically, like with variables and exponents and numbers, and then written out as words, but don't worry about that too much. Okay? What we're going to do here in example 1 is practice evaluating a function, meaning given different input values, what is our output value? So the first thing I want you guys to recognize is what f of x is. What's another way we could call f of x? F of x is the same as y. We know that, right? That's all it is. And if there's something in the parentheses in the f of x place, it represents x. So all we're going to do in these examples is substitute whatever they're giving us as our x value into the function for all the x's that are in the function. Okay, so we're just substituting in and simplifying using order of operations and simplifying this. 3 squared, we do exponents first, right? 3 squared is 9. 9 times 2 is 18. 5 times 3 is 15, add them together, and we get 33. Okay? So pretty simple, right? Plugging in x, when x is 3, y is 33. Okay. Let's look at b. F of x plus f of 3. Well, they're not giving us a value to plug in for x. F of x is just this. That is f of x. F of x is 2x squared plus 5x. Like that. And we just did f of 3. F of 3 is right here. We don't need to do it again. Right? F of 3, we just did it. And really there's nothing else to do. This answer is considered to be in standard form. Our exponents are in descending order. And there's nothing we can combine. We can't add any of these together because some are squareds and some are x to the first. That's it. That's all you can do. Okay? Moving on, we have a number and a letter. And even though this is not difficult, there are some common mistakes students make in a lot of these. That's why we're taking the time to go over them, kind of move through all the issues we could have with stuff now. So everywhere I have an X, I plugged in a 2X in parentheses. So don't forget what parentheses mean in math. It means all of this. So when there's parentheses and there's a squared, that means you have to square everything that's in the parentheses. So 2 squared is 4 and X squared is X squared. Okay? You can multiply these together, you would get 10X. Multiply these guys together, you get 8X squared, and then just bringing down the 10X. It's in standard form. There's no like terms we need to add together. The exponents are in descending order, and that's it. Okay? In the next 2 examples, we've got negatives to deal with. Where a negative is matters. I'm sure you guys could assume that. This is saying make the y negative, make the whole function negative. So what that means is whatever f of x is, we're going to put a negative in front of it. Why am I using parentheses? Because I need to apply the negative to all of f of x. If I don't use the parentheses, it would just get applied to the first term. So we know, I think, that whenever you have a negative in front of parentheses, it changes everybody's signs. So if you're positive, like both of these, you would switch them to negatives. If one of them had been negative, you would have switched it to positive. Just changes the sign. So that negative in front means change everybody's sign. Versus a negative on the inside means change who? X, right? It says change X's sign. Well, we'll just plug in a negative X everywhere we see an X. And let's talk about this. When you have a negative number or letter to a power, it's really important to know what the sign should be. So even number exponents, 2, 4, 104, 2098, an even number power will always yield you a positive answer. Think about why. Every 2 negatives you have is positive, okay? So negative x to the second power will resolve down to positive x squared, okay? Now, if you're an odd number exponent, let's just use 3 as an example. For every 3 negatives, if you have 3 negatives, for every 2, those become positive, so there's always going to be a leftover negative. So if you have an negative x to the 5th power, 55th power, 179th power, it's going to stay negative. So this is going to be a negative x times 5, which is negative 5x. Okay? So just being careful about how you apply your negatives. And last one of these, plugging in a binomial. So pay attention here for sure, because there's a mistake in here I always see students make. So just like the others, I'm going to take out the x's and plug in the x plus 3 in parentheses. Okay. Now I'm going to tell you what x plus 3 squared is not. X plus 3 squared is not, and this is a common mistake, it is not x squared plus 9. Okay? You don't just square the x and square the 3. When you square a binomial, you don't get a binomial. When you square a binomial, you should get a trinomial. Okay? Now there's a shortcut to do it, which I'll show you in a second, but just to review what you guys have probably done in the past is FOIL. So if I took x plus 3 and I wrote it out twice, which is what that means, it's called the distributive property or factoring, right? X times 3, 3 times x, 3 times 3. Real quick, you don't have to write this if you don't want to. Right? If I FOIL that out, I would get that, and then you would combine like terms. Let me squeeze this here. In the middle, you would get 6x, right? If I combine those two. So I would have x squared plus 6x plus 9. And that's a fine method, nothing wrong with it. But I will tell you that we square binomials in this class a lot. So to know the shortcut could just make your life a little easier, but I don't care which one you do. Okay, so let me show you. Let's go back up to the problem. To square a binomial without having to do the work, this is what we're going to do. We we're going to start with the two terms that are in there and square them both. And they're going to go in the same spot in the parentheses here. So if I square an x, I get x squared. If I square a 3, I get positive 9. Okay? But don't forget, there is a middle term. How do we get it? We multiply the x and the 3 together, 3x, and then times 2. Why 2? Because remember, you're always going to get the same thing in between, the 3x twice. So that's where we get, sorry, squeezing it in there. So that's x squared plus 6x plus 9. What does it kind of feel like? The SOAP problems. Remember, we would square both of them, and then we would multiply them together and put it in the middle. This is one difference. Square those two, and then multiply them, the two numbers together and double it. And it's because of this right here. Okay? And then I'm going to distribute here. Let me distribute here as well. Just bring all those down. Now, knowing when you're done in a problem is half the battle, right? This is not in standard form because there's some like terms in here I can combine. So as one last step, I'm just going to write it in standard form. Biggest exponent goes first. 12x plus 5x is 17x. And then 18 plus 15 is 33. Okay? So just some practice substituting in values. Questions on that example? Turn the page. And you'll see me cross things out. Like I told you before, I don't do every single problem. You can kind of just follow along with me as I go, but I'm just making a point. Like, I don't want you guys to look at a whole page and just be like, oh my gosh, there's so much, because I really do try to narrow it down. I pick what's important and what gets the point across, but without beating a dead horse, okay? So next example is identifying domain and range and then saying if it's a function or not. So I told you I'd come back to the idea of a relation again later. Here they are. These are examples of relations. They're just sets of ordered pairs in lots of different ways. Here's just literally a set of ordered pairs. This is a mapping diagram, x values and y values mapping to each other. And then graphs. Those are relations too, because that's what graphs are made up of. It's a bunch of ordered pairs. So we should be able to very easily name our domain and range. And it does not matter what order you put them in for this class. Just list them. All your x values, that's your domain. All your y values, that's your range. Literally listing them. And then we're going to decide if this relation is a function or not. Remember, my kind of simplified definition was, are there any repeat x values? Do I use any x value more than once in this relation? No. So is it a function? Yes, it is a function. No repeat x values mean it is a function. In our mapping diagram, listing the D and the R, really, really easy. Okay, so domain, list them. Right, that's your x's, domain. Your range, any order. And then the way you read a mapping diagram, I'm sure you know, but they're ordered pairs. -6 and -4 go together, -3, 0. And look at the 2. It has 2 arrows coming off of it. That means you use the 2 twice. So is this a function? No. Okay, so those domain and ranges are pretty easy, just pull them right out of the information given. And we should also be able to pull out the domain and the range from a graph. When we do this, my darlings, you must use interval notation. Okay, so here it is again. If you did not get interval notation right on that quiz, which I know you might not know right now, it's going to come up all the time. We use interval notation almost every day, right? So looking at a graph, we always do least to greatest, okay? And how do we read the x's? From left to right. That would be least to greatest. So the first x value we come to is -4, right? That's the first x value we use, -4. And then it goes to the right when you see an arrow forever, right? So the domain is from -4 to positive infinity. Bracket on the -4 because it's included, right? It's a closed-in circle, bracket, and we always use parentheses on the infinity symbol. Range, we don't read left to right, we read from bottom to top, least to greatest. So if I travel up the y-axis, the first y value I get to is -2. That's the first y value we use. And then as it goes to the right, towards infinity, it also goes up towards infinity. That's what that arrow means. And since -4 is included, well, -2 is too. It's a closed-in circle at that point, always parentheses there. And we could do the vertical line test to see if this is a function or not. No repeat x values. You never would use the same one twice, so this is a function. Okay? Now, probably the coolest part of this whole set of notes is some fun thing I'm going to show you on your calculator. What we're being asked to do is find the domain, and it doesn't say if she does mean the range. Same exact questions up here. Domain, range, and is it a function or not? But instead of having to remember, how did I graph this in my Algebra 2 class, and blah, blah, I'm going to show you how to graph it on your calculator. Super easy, okay? You're going to love this. But first, I want you to clear your RAM. Clearing the RAM on your calculator takes out whatever the person that was using it before you, all the stuff they put in there, and it clears it back to nice and like a clean sheet of paper, okay? And so you'll learn to do this a lot. I do it almost every time I pick up a calculator. When I come around and help you guys and you're like, I don't know why it's doing this, I'll clear the RAM and start over again. It usually fixes the problem. It seems like a lot, but after you do it a few times, you will just know how to do it, okay? So you hit your second button, and then just hit those buttons. Plus 712. You can do it really fast. You don't have to wait. Second plus 712. And you should get a message that looks like this. RAM cleared. Second plus 712. And then you can just hit the clear button, and it just brings you back to a blank screen. Okay? Now, let's put this in. We're going to put this in and tell it to graph it. So here's what you do, guys. Look. Y equals. This button right up here, y equals. You can see it gives you a whole bunch of y equals. And we're going to type that function in. So I'm going to put the square root in. We learned how to do it the other day. Second x squared. Right? It's blue, so you have to hit the second button. So you should have a radical there. And then you type in 4 minus 2, and then we need an x. And there's a button on here to do variables. How cool is that? It's right here. It's next to the alpha button. Hit the X. Good. Now hit graph. Where's graph? Next to alpha. It's X comma T comma theta. Okay. And now you're going to hit this graph button right here. Okay. See top right. It says graph. Now that'll graph the picture for us. Okay, great. But I have to draw that. Sketch it. It doesn't have to be perfect, but I want to know what point that is and what point's that. And so I can kind of guess. It looks like it's around 2 on the x-axis, but watch the coolest part. Coolest part. Above the graph button, do you see the word table? It's in blue, so to access it, you have to hit second, and then hit table, and guess what that is? That's all the ordered pairs. That's your table of values, or XY chart that makes up this graph. And so you can see we have a point at 0, 2. Okay, thank you. 0, 2. Put that on the graph. And you can use your arrow and scroll through. Oh, I don't care about that decimal. That's a pain. But look, there's, I'm sorry, not 0, 2. 2, 0 was my x-intercept. But look, there's another point at 0, 2. Let's scroll up a little bit more and see what else we have. Hit the blue button second, and then the word graph, because the word table is in blue. Where'd it go? And then I can go, look, there's another nice point, -6, 4. So I put the graph on my calculator. So I made it, so I know what it roughly looks like, but I wanted to have some good points to put on my graph. So I used the second table and found some nice values. So I found ones that were easy to graph, and I already saw what it looked like, so I know it goes in this direction. And even though your graphing calculator does not do arrows, it won't show you an arrow. You know it keeps going towards negative infinity because if you keep scrolling, look, it goes on and on forever. I'm just holding my button down to keep going, and you can see I'm getting smaller and smaller, and I still have values. So that's showing that it goes that way, okay? So that's going to be super helpful. Think about how that could work for you on SAT or ACT. All right. Now, domain. Everyone's getting this wrong today, so pay attention. The domain has to be least to greatest, left to right. We didn't graph it like that. We started at 2, and then we made our pen go towards the left. That's how we graphed it. But to read it, you have to see that it's coming from negative infinity all the way up to 2, including the 2. Least to greatest, so be careful with that. Range, the first y value we use is 0, and it goes up forever. Okay, so be careful with that domain. That's a common mistake. And yes, this is a function as well. No repeat x values. We're almost done, I promise. One last example. So I'm going to do one last example with you and then tell you about your homework. And then there's 2 of these in your homework. I would do these first in case you don't have the app on your phone for a graphing calculator or whatever. I'll tell you what I mean when we get there, just so you can get the 2 done. Anything else you can do on any kind of calculator. All right, like I told you, lots of times she, the lady that made this stuff, puts lots of words, lots and lots of words, okay? Sometimes they're important, and sometimes I'm going to say, you know what, you can read that if you want to, but I can teach it to you better by showing you than reading the words, okay? So our last example is example 4. Let's go right to that. Okay, now I have colors to pull out parts of this graph. If you don't have colors, that's fine. This is really easy, okay? You can make little X's for increasing and stars or hearts, something along it if you wanted to. Okay, so AP Pre-Calc wants you, they're huge. This whole unit is about looking at graphs and pulling off information. We've already done domain and range. Now we're going to do something called increasing, decreasing, and constant, okay? Super simple concept. Where a graph is increasing is where it goes up. Decreasing is down. Constant is where it just stays horizontal. So if I just look at this graph they gave us, g of x, you would say it's decreasing right here. It's going down, decreasing. It changes directions right here, and we start increasing here. Constant, decreasing. Okay? So, green for increasing. Do you guys agree that this piece of the graph right here is increase? That's the only piece where it's going from lower to higher, okay? Now, when we name this interval, so we're saying from this to this, we use the x values. That's a little confusing because when we talk about increase and decrease, it's kind of up and down, the y's. But when we name these intervals, we say what part of the x-axis is the graph increasing. So you kind of have to zero in. We're increasing from 0 to what? 2. From 0 to 2. And remember when we just did domain and range a second ago, and we're going to do it again, and I said to you, interval notation. You have to use interval notation for domain and range. There's a huge fight going on in the math world, and I'm not being funny. Literally people fighting about how to properly state these intervals. And the answer for us is parentheses or brackets. This is one of those times I'm not picky, and neither will the College Board. When you get questions about increasing, decreasing, and constant, it doesn't matter which one you use, okay? You might see me sometimes use parentheses, sometimes use brackets. I kind of like parentheses better, but it doesn't matter, okay? Interval notation matters for domain and range. Okay, now, decreasing. We're decreasing on this piece of the graph, right? Going down, and we're going down here. That's where we're decreasing. And don't forget what these arrows mean. So this graph, left to right, is coming from the left. What's to the left? Negative infinity. Where does it stop going down? I think that's 0. My graph's yucky. Is it 0, guys? It's 0. right? All of that. I'll use parentheses. And you can put a union symbol, you can put a comma. We're not picky about it on these. Okay, so you might see a union, you might just see a comma, because there's a second decreasing. So look at the x-axis from 5, right? That's where it starts to decrease, and then it goes down forever to the right, which would be positive infinity. So those are the sections of our graph, the intervals, where we go down. And I think you all can agree this would be constant, doesn't go up or down. Look at your x-axis, that's 2 to 5. Okay? Yeah.
My question is, why don't you count the bottom part where it does
I think because you're thinking of the, here all we use is the x-axis part. What part of the x-axis is it like that? That's the tricky part. It's a common question, common mistake. It's something you have to train yourself to say. When you're naming what part of the graph goes up, down, or stays the same, it's what chunk of the x-axis it's happening on, okay? Domain, let's get these done real quick because those are our last two questions. Domain and range. We know what these arrows mean. It goes up and to the left forever, down and to the right forever, and everything in between is being used. Meaning, we haven't even talked about it yet in this class, there's no asymptotes, there's no open circles that are holes. We use every value in between here and forever, up, down, left, right. So for both of these, it's negative infinity to infinity. Okay? That is good with that? Now, if you turn the page, I think maybe in the back, wherever, you're going to see 1B or whatever, however she does that. That's notes for next week, okay? Keep flipping, flippity flip, to get to practice set. Let me get to it. It has been a day, y'all. It has been a day. You should see, so practice sets are your homework. Printed for you. You just get to write right on it. So 1.1 practice set 1, that goes with day 1, or A. There's a practice set 2, that goes with day 2, or B, okay? So we'll get to know it, don't worry. But remember, I told you guys that I don't assign the whole thing, all right? There's a lot more problems in this section than I want you to have to do. I painstakingly go through and pick enough that I feel like you should be okay, and anything I find important. So until I figure an easier way of doing it, we're just going to have to write it down. So A5, we're still labeling. These are the only problems. And there is an FRQ page, and you're just doing those sections, okay? Don't worry about name, date, period. This is staying in your notebook, so that doesn't matter. Don't waste time with that. So everyone should be writing this down. Another suggestion to you guys is, and this just suggestion to save you what happened to some students today, maybe take an extra 12 to 13 seconds and circle the problems. Did I not have that up there for you? No. It was? Okay. So I go through and I circle the problems and I kind of lightly cross out the ones I'm not doing. That way when I'm working, I'm not having to keep flipping back to see what problems to do. Okay? I could make our lives easier and just say do them all, but that's ridiculous. There's no reason to do them all. So it's worth taking a couple extra seconds to write that down, and if you want, circle and cross out. That way, as you're working on your homework, you don't accidentally spend time doing problems that are not assigned, okay? But as you can see, all the answers are here, even though I crossed them out because they're not assigned. So if you ever wanted to practice more, they're there for you, and this is on Canvas, okay? So when we start homework in class, I'm totally down with you opening your laptops and pulling this up on your laptop because it's easier than looking up here because everyone's going to be on different pages at times. So just a suggestion, having your laptop to help you get through it, because some days you'll have a lot of time to work on homework, some days 10 minutes, so it just depends. And I cannot make everybody happy up here, okay? So remember I said if you don't have a graphing calculator yet and you didn't put the app on your phone, remember this? I gave you guys this, if you want to put this on your phone, Apple, Android, free, and it gives you a graphing calculator that looks exactly like the one we use in this class. Very, very, very nice. So Calculate 84, free app. I have it on my phone. I love it. But eventually I should be able to give you one. Anyway, maybe do number 5 and 6 first, because those are the ones you have to like put on your graphing calculator and sketch. Look, not even perfect. Very, very simple. So I'm just going to show you how to do number 5, because everyone was asking about that today. So if you go to your y equals, and you probably still have that guy in there, you can just hit clear. It'll clear it out. So clear is right here. You don't have to reset your RAM and all that. Just hit clear. Domain is X, range is Y. So go to y equals and hit clear. So y equals and then clear, and then you back to blank space. So x to the power. Here's your power button, guys, right here. It's called a caret. That's how you do the power of anything. Okay? I'm almost done talking, I swear. If your calculator does what mine does and it puts the exponent up in the air, that means your calculator is updated at the moment. You're good to just type it in like that. If it kept it on the ground, I still have to update your calculator. I'm going to get some NHS students to do it for Bright Futures hours. Anyway, you just have to put the 2/3 in parentheses. How did I get that slash? Divide. 2 divided by 3. So again, x to the power of 2 divided by 3. And then graph. And just sketch it. It does not have to be perfect. You don't even need to look at the table. You can see what it's supposed to look like on my feet. Okay? So here's the first page, but the whole thing is on Canvas. I will come around and check on y'all in just a moment. You're going to make me have to dye my hair more often. Not so. Please write them down when I put them up. Good? Everybody got it? To what part?